It's kind of a summary. Alright, an application. It took 20 seconds for a thermometer to rise from 10 degrees Fahrenheit to 212 degrees when it was taken from a freezer and placed in boiling water. Explain why the temperature increased exactly, increases exactly 10.1 degrees Fahrenheit per second at least once during the 20 seconds. Well, here's a visual of it. I do a graph. I don't exactly know how the curve works, but here's one by Newton's law of cooling. It probably does something like this, but it would be continuous. And if I would find the slope of my secant, which would be change in temperature over change in time, and I'll draw that for you like that, then I can find the slope of that change in temperature over change in time, and I've got the work shown right here. So that the slope of the secant is 10.1 degrees Fahrenheit per second. So I know at least one time that this temperature was increasing at that rate. It's kind of intuitive, actually. Now here's another application. The 25-mile marker on the Pennsylvania Turnpike, you pick up a ticket at the toll booth. At the 30-mile marker, you decide to get off the turnpike. Too much road construction and the speed limit is only 45 miles per hour. You pay your toll and start to pull away when a policeman walks up and gives you a speeding ticket. No way, you say. I was only on the turnpike 5 minutes. Why did you get this ticket? Okay, so here I show time along the x-axis, distance along the y, and you traveled for 5 minutes. So you were going, I'm going to do it miles per hour, so you're going a 1/12 of an hour. So your change in distance was 5 minus 0. Your change in time would be the 1/12. So you traveled an average, this is your average, of 60 miles per hour. Well, Mr. Policeman could walk up and say, by the mean value theorem, you were traveling at least one time at 60 miles per hour, which is obviously 15 miles over the speed limit. So here's your ticket. So there you go. Sorry, buddy. Now there'll be other applications in the book for the mean value theorem when we do some of the homework, but this is essentially how it works. You have to be continuous on a closed interval, differentiable on an open interval, and then the instantaneous rate of change and the average rate of change are the same at least one time on that closed interval. On the open interval. All right? Have a good day. Bye.